In this video, I want to show you how you can use the 68, 95, 99.7 rule to do a normal distributions problem. In this problem, we have the total scores of the Medical College Admissions Test, also known as the MCAT. And these scores are known to follow a normal distribution. So in 2010, the mean MCAT score for all who took the exam was a 25. So that is mu is equal to 25. And it had a standard deviation, so sigma is equal to 6.4. And so if we want to find the percentage of people who took the MCAT in 2010 that scored below 25, then the first thing that we should do is we should draw the distribution. This is always a good idea. So we draw our normal distribution, and in the center we put our mean. And then from here we want to then calculate the 1 standard deviation, 2, 3 standard deviations up from the mean, 1 down, 2 down, and 3 down from the mean. This is important because then it gives us a nice kind of idea of what our distribution looks like, and it'll allow us to easily then answer questions from here on out using the 68, 95, 99.7 rule. So the first step is to start with the standard deviation up from the mean, which is going to give us 31.4. I can find this by simply adding our 6.4 to 25. That's 1 standard deviation up. 2 standard deviations up is going to be 37.8. 3 standard deviations up from the mean will be 44.2. And just filling in the rest, so 1 down from the mean will be 18.6, 2 down, 12.2, and 3 down will be 5.8. So now that I've drawn my distribution, I want to then always shade in the region that I'm curious about. So what percentage of people who took the MCAT in 2010 scored below 25? Well, I can easily find this. Let me get a different pen here. There we go. If I want to shade in this region, it's easily visible that this is going to then be 50%. So why I know this is, one, I can visually see that it's 50%. It's about, half of the distribution, but also because the mean and the median are the exact same thing for a symmetric distribution, and the median is always going to be the cutoff value for 50% of our data. So it's the 50th percentile. So here our mean will always represent the cutoff for 50%. So let's go ahead and put in our answer here, 50%, because it wanted percentage. If it wanted proportion, then we could, this is the same as 0.50. Doesn't matter what we put in. Just make sure that we understand what units we want to put it in. All right, so for the next problem, we want to then find the percentage of people who took the MCAT in 2010 that scored between 12.2 and 37.8. So we can do this by again shading in the region because we have already put in our standard deviations. Basically, we just need to say, okay, it's in between these 2 points. Shade this in, and from the 68, 95, 99.7 rule, we know that this is 2 standard deviations away from the mean. We can see that this is easily then 2 standard deviations up and 2 standard deviations down. So this implies that this is 95% of our data fall between 12.2 and 37.8. This is from then the 68, 95, 99.7 rule. So answer here is 95% of the students score between 12.2 and 37.8 on the MCAT. Again, this could also be 0.95. All right, so for the very last problem, it says approximately what percentage of people who took the MCAT in 2010 scored above 37.8? So now let's go ahead and leave in our shading that we did before, because we know that if we are looking at this area, the area that falls above 37.8, this is what we want to know. This is the mystery. Well, we know that between 12.2 and 37.8, that 95% of our data is between those 2 points. And we also know that under the entire curve is 100% or 1, so 100% minus 95% is going to then be 5% that's left out here in these tails. So here and here is a total of 5%, right? Well, this is a symmetric distribution. So what that means is that I have to split this 5% in half. Down here there will be 2.5%, and up here there will be 2.5%. So by visualizing the data and using the 68, 95, 99.7 rule, we can get a nice approximation for a lot of these normal distribution problems.